Hello.
Hello.
Yes, ma'am. We can hear.
Okay, so how are you?
Fine, sir. Fine, ma'am. How are you? You?
Yeah, I'm fine, thank you. Okay, so did you practice those two search algorithm, that is binary search and linear search algorithm?
Not yet.
Do you need any more discussions on those two topic, or it's clear to you? Hello.
Hello.
Hello, can you all hear me? Yes, I'm just asking
Yes, ma'am.
that do you need any more discussions on those two topic? One is linear search algorithm and another is binary search algorithm.
Um,
I'm not getting any response, so how we can start the next
Ma'am,
topic?
ma'am,
At first, I need to know whether you have problem on the
ma'am,
previous
it
topic
would
or
be
not.
better to
Yes?
discuss the previous,
yes,
that
ma'am.
is
Shortly brief the
about
previous
the
topic.
Yeah, definitely. Yeah, definitely. So our last topic was we just discussed about two search algorithm. What is search process? This is just an operation that you can use on any data structure. Okay.
yes, ma'am.
So search is an operation which is used for searching a data item from a data structure. And that data structure can be array, stack, or queue. But if we want to execute a linear search algorithm, at that time the data structure should be an array, and the data elements that you can store, it can be arranged in any order, or actually it's not mandatory to maintain the sequence or ordering. The array can be sorted or unsorted. So suppose these are some data elements stored in the array 4, 5, 9, 2, 1, 7. And another, you can take 3 more elements. Okay, then 12, 11, and 3. Okay, so this is an array, and is this array sorted or unsorted?
Unsorted, ma'am.
Unsorted.
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 And the capacity of this array is here. Suppose max size equals to 9, and the array is full. We have taken 9 elements, or 9 elements are stored here. Now, if we want to search a data item that is 12, if we want to find out the location of the data 12, we can use two search algorithm. One is binary search and another is linear search. But here the array is unsorted. That's why we can use
Linear search.
linear search algorithm. Okay. So what is the property of linear search algorithm? Its property is always it will start the search operation from the first memory location, and sequentially it will search that data item in all the memory locations. So here lower bound equals to 1 and upper bound equals to 9. So it will execute such operations until it gets the data item 12. Okay, so here 12 is stored in position 7. That means in linear search algorithm 7 times the search operation will be executed. After that it will get the location of this array. So here the number of such operation depends on the position of that data item in the array. That's why the time complexity is order of n. This is linear search, and the algorithm will search all the locations from the first one until it gets the location of the expected data item. That is linear search algorithm. And another algorithm we can use, that is binary search. Binary search algorithm, at first the data needs to be sorted. So here we can organize the data in ascending order. So the first data will be, the lower data element will be stored in the left side of the array. So at first we can store 1, then 2, and the third data will be 3, then 4, that 5, and then 7. Seventh data element will be 9, and then 11. Last one is 12. So this array has 9 elements and the lower bound and upper bound is same. Lower bound equals to 1 and upper bound equals to 9. So if we want to find out the same data 12, okay, we want to just know in which location the data is stored. Okay, so now the binary search algorithm, at first it will reduce the size of the array by half, right? So here the data element is 9, so we can divide this array into two sub-array with equal number of elements. But here in this array the number is 9, it's an odd number, right? So how we can divide this array into two half?
By find out the
Mid
meat.
equals to lower bound plus upper bound divided by 2. So 1 plus 9 equals to 10. 10 divided by 2 equals to
5.
5. So this middle element 5 is the middle element of the array and its position is 5. So now we can divide the array into two halves. This is the first half of the array with 4 elements and this is the second half of the array with 4 elements. Okay, so now the data item is 12 and the array is sorted. That means all the data elements that is smaller than 5 will be placed in the first half of the array and all the data elements that is higher than the mid value we can find it in the second half of the array. So here mid equals to 12 which is greater than 5. That means the data item, we should look the data item where in the right side of the array, in the second half of the array. So that means now we will search the data item only in this half of the array, so we can ignore this part of the array, right? So now we have to change the lower bound value or upper bound value.
Lower bound.
In this array the upper bound equals to 9 but the lower bound value
6.
has changed. So how we can change it? We just
Mid
have
plus
to
1.
add 1, right? So here if we add 1 with the mid value, we'll get the new value of lower bound. Lower bound equals to mid plus 1 and here the position of mid element is 5. So 5 plus 1 equals to 6. This is now the lower limit of this array and the upper bound is 9. So again we have to divide this array into two halves, right? So how you can divide it? Again you can find out the mid value of this array. Lower bound is 6 and the upper bound is 9. So 6 plus 9 divided by 2. 6 plus 9 that is
7.
15. 15 by 2, 7 point. That means 7 and 8, both these items can be considered as a mid item. We can take 7. Suppose this is our mid value. Okay. So now if these two elements are mid value, we can divide the array into two sub array with one element. Now this part of the array has one element 7 and the second half of the array has another element 12. So the data item 12 is greater than the mid element, right? The new mid element is 9 and 12 is greater than 9. Okay, so now tell me from which position the algorithm will, search the data item. From the position 8 or from the position 9? Look at this. After taking only one element as the middle element, suppose we took which one?
7.
7 is our middle element. So where we can include this
8
element?
from
Now 8
8.
is not the middle element. So
8.
where, in which half of the array will add it? In the second half of the array. That means the left side of the array has one element, but in the right side of the array has two elements. Isn't it? One is 8
Yes,
and
ma'am.
another is 9. So at
9.
first it will search the array in this position. Can it do it? What is the concept of binary search algorithm? Always it will find the data element where in the mid position. In the mid position. So if I say that both the 7 and 8 positions element can be the middle element, but we have to choose only one, either 7 or 8. So which one we took? 7, right?
7.
If this
Yes,
two
ma'am.
element can become the middle element, that means the 7 is one half of the array and 12 is another half of the array. So does that mean can we? I mean, it's possible to ignore this element 8.
Madam, in that case, yeah, possible, madam.
Is it possible?
Yes, madam. If we consider both of
Yes,
them
it's
as a
possible.
midpoint,
It's possible. Yes. So now when item 12 is greater than the mid value, at that time it will look the data element were in the second half of the array, and here in this second half of the array there is only one element 12 in position 9. So here mid 9 equals to 12 equals to the item, right?
yes, yes, ma'am.
Yes, ma'am.
So at that time the algorithm will return the location of that item, that is 9. So that is binary search algorithm. And what is the time complexity of binary search algorithm? Order of log n. Because each time we are reducing the data into half, right? And for each portion of the array, we are performing how many search operation? One search operation. Okay, so the relationship between the input size and the number of operation is log n. That's why the time complexity is order of log n. And that is binary search algorithm. Is it clear? Or do you
Yes,
want to
ma'am.
practice another one?
Yes,
Should I
ma'am.
give you another data set so that you can find out the location of the data
Yes,
or
ma'am.
the item?
Yes, ma'am.
Hello? Okay.
Yes, ma'am.
So I'm just giving you a
Madam,
data set. Yeah, Tanvir.
madam, can we consider after dividing the whole array, then can we consider two variable as a midpoint each time?
Sorry?
At each division, I want to do two elements as a midpoint. Can I do that?
When we have two elements as a mid element, then which one we should
Yeah.
take?
No, madam.
Okay, it
I
depends on
can I
you.
put a
If you
condition
want,
like
you
this,
can
madam?
take the second.
Yeah.
Sorry?
Madam, I want to put a condition. First, uh, after dividing a array in two part, if the one side is containing odd numbers of elements, then I should make one midpoint. And if the number is even number of element, then can I make the midpoint two with the two element?
You want to take two mid element.
Yes, so when the total
But
number of
actually,
element is
we are
even.
look, in the previous example, how many mid elements we took? Actually, two, isn't it?
Yes,
Although we are
yes,
considering only one, but the other one we are just neglecting it. That means we are considering both those elements as a mid element,
yes,
isn't it?
madam. But in that time, madam,
Yeah.
we didn't put any condition that if the number of elements, if the odd number of element is there, then take one as a
Okay, in the
midpoint.
algorithm, if you want, you can just set the condition. You can write an algorithm in several ways. Okay, if you want, you can set that condition there. Okay.
Okay. Yes, ma'am.
Now I'm just giving you another data set, that is 32, 13, 25, 46. Okay, so apply binary search algorithm to find the location of the data 46. and look at the data set. The data is not sorted, right? So at first sort the data element and then apply binary search algorithm. Clear? And I'm just giving
Yes,
you
ma'am.
5 minutes time, so please try to complete it within 5 minutes.
Ma'am, done.
Done, madam.
Done,
Very
ma'am.
good. Okay, so just tell me how many times we have to execute that search operation?
2 times.
Only 2 times. Okay. So at first we can take the data. So the first one will be
7,
7,
7,
9,
9,
and after
12,
that 9,
12,
13.
12, 13.
Okay. So there. Okay.
21,
And after that
29.
25,
5,
29,
29,
32,
then 32.
46,
Yeah.
56, then 65.
46, and then 65.
65.
Okay, so this is our array. Now lower bound equals to 1 and upper bound equals to 11. So the mid value of the array will be 1 plus 11 divided by 2, that is 6.
6.
So this is the middle element, and now if we divide the array into two parts, the left side of the array has 5 elements and this sub-array has 5 elements, right? And here the item is 46 and the mid element is 25, which is smaller than 46. So in which side you should execute the next search operation?
Right side.
The
The
right
right
side.
side of the array, right? Yes. So here now we have to change the value of lower bound,
Lower bound.
right? So the value of it will
Lower
be
bound
mid
equal to
plus
7.
1 equals to 6. So 6 plus 1 equals to 7, and upper bound equals to 11.
11.
Now again you can find out the mid value. Mid equals to 7 plus 11, that is 18. 18 divided by 2, 9.
9.
Okay, so this is our item, right? Here we can see that if the name of the array is A, so A mid, that is A 9 equals to 46, which is equals to the item.
Item.
So after that, the algorithm will return the location, that is 9. Very good. So is it clear to all of
Yes, ma'am.
Yes, ma'am.
you?
But ma'am, how can we write the steps? The
Now we
algorithm.
can write these steps. Okay. So step number 1, at first we have to take all the parameters, that is lower bound, upper bound, size, and then the item, right? After that we can start from, we have to, do we need to use any loop variable here?
Yes, ma'am.
Why you need the loop variable?
To transfer to madam to search every element, each element.
So if we know the limit of the, I mean lower bound and upper bound, suppose here lower bound equals to 1 and upper bound equals to 11, and that is actually n, right? And then we can set a condition, that is while lower bound less than or equals to n, or lower bound less than or equals to upper bound. What should be the condition? While lower bound less than or equals to upper bound, or lower bound less than or equals to n, then we have to find out, we have to calculate the mid value, right? Mid equals to lower bound plus upper bound divided by 2. Then we can set another condition, conditional statement, that is if else. So if here the item, if the item equals to the mid element, then return the location, what it will return. If the condition is item equals to mid, then which value it will return? Obviously the mid value. The mid value will be the value of location. Else, if the item less than the middle value, then we have to increase the what is the first condition? If item equals to mid element, then return the location of that mid value, isn't it?
Yes, ma'am.
Yes, ma'am.
And another condition can be if item less than the middle value, then which value we have to change? The value of upper
Lower
bound.
bound.
Upper bound.
The value of
Upper bound.
upper bound. Here the item is 46, right? That means 46 is greater than middle. At that time you have to change the lower bound. But suppose we are looking for the item 9. At that time 9 is less than 25. So which value should be changed? The upper bound value.
Upper bound.
So if item less than the middle element, then upper bound equals to mid minus 1. Or else, if the item is greater than the mid value, then you have to change the value of lower bound. Lower bound equals to mid plus 1. So that is the algorithm. So now I think you can write the steps.
Ma'am,
Yes?
ma'am, if 46 change, then 46 change 12 or 8. When which operation we control, ma'am? Upper bound or lower bound?
I didn't get your question.
Ma'am, yeah, 46.
Yes,
Change.
that is an item. Yeah.
46 change like as 10.
If the item
Then-
is 12.
10. 46 change.
But we didn't insert any element. Okay, we can assume that the item is 10. Okay. Please complete your question. Hello. Hello.
অ্যাকচুয়ালি ম্যাম আমরা যখন 46-এর পরিবর্তে যদি -9 নেই, সেক্ষেত্রে যে আমরা লোয়ার বাউন্ডের সঙ্গে 1 যোগ করতেছি বা মাইনাস করতেছি, এটা একটু বুঝলাম না ম্যাম।
What is the concept of binary search algorithm? Here we are not going to linearly search all the locations, right? Binary search always reduces the data size, and how it reduces? By half, right? Or if the data element is 12, then after, we have to divide that array into 2 sub array with 6 elements, each with 6 elements, right? So look at this. If the item is suppose 12, okay, this is our array with 11 elements, right? And at first we will divide the array into 2 sub array. And now look at this sub array. This is the first sub array with 5 elements, where lower bound is 1, and we can, is this our upper bound? For this sub array, actually 5 is our upper bound. Okay, and this is another half of this sub array where 6 should be the lower bound and 11 is the upper bound, right?
Yes, ma'am.
Isn't it?
Yes.
Okay, so now look at this. If 25, if 6 is the mid position of the array, that means 25 is the middle element. Now we have to check whether the item is equals to middle element or not. And here the item is 12, that means it's not equals to the middle element. Now we have to check whether it is smaller than middle element or greater than the middle element. 12 is smaller than middle element, and this array is sorted in which order? In ascending order. So we took all the lower elements here in the left side of the array, and all the higher elements are stored here in the second half of the array. So obviously we have to execute the next search operation on which side of the array? The left side of the array, where all the data elements are smaller than the middle element. Right? So at that time, we cannot use the upper bound value 11 because this sub array has only 5 elements from 1 to 5. That's why we need to change the value of upper bound. Isn't it? So how we can change it? The mid value is 6. So now if we subtract 1 from that mid value, that is 6 minus 1, that will be the new value of upper bound for this sub array. Is that clear?
Yes, ma'am, clear.
Okay. Any other question?
Madam, how to find the last element
How to find the last element?
or the first element?
Or okay. So suppose we want to search the data item 65. Okay. So at first we divided the array into two sub array, right? And 6 was the mid value. Okay. And now after that, again, you can, when 25 is not the actually expected data item, then again you can divide the array into two sub array, right? So the
Yes.
lower bound is 6 and the upper bound is, sorry, the lower bound is 7 and the upper bound is 11. So 11 plus 7 equals to 18. 9 is the middle element.
Yes,
Okay,
ma'am.
so now the item 65 is greater than 46, isn't it?
Yes, ma'am.
So now we'll perform the next search operation
10 plus 11.
on this sub array.
Yes, ma'am.
But again, another rule is we can only search in which position, in the mid position. When the middle element, this 9 plus 46 is not the expected data item, again, we can divide the sub array into two halves, isn't it?
Yes, madam, but there will be no meat.
Hello?
Yes, ma'am. Hello.
Yes, ma'am.
Yeah, so now look at this. The lower bound value will be changed. Now the lower bound equals to 10, isn't it?
Yes,
And
madam.
what about the upper bound?
11.
11. So 10 plus 11, that is 21 divided by 2. 11
Yeah.
point something. 11
Yes, ma'am.
point something. So since
And 10 point
11 is
something.
10 point something, madam. 10.
10 point something. So here we have to consider both this 10 or 11 as a middle element. So we can just choose one. We can choose one, right? So
10.
if we choose the first one, then at that time it's not the middle, it's not the item. It's not the item, so we can take the second element as a middle element, and after that we'll get the expected item here.
Yes, ma'am.
Clear?
Clear, madam.
Okay. So
Ma'am,
that is
in the exam, do you need to write the algorithm? Or
in exam,
yes, ma'am.
you don't need to write the algorithm. You just have to show all these steps.
Okay, ma'am.
Okay.
Okay, ma'am.
So now we can start the next topic. I think so. Can we?
Yes, ma'am.
Yes.
Okay. So we are actually discussing about the queue. Remember, we are in which data structure? Queue. And what is queue? This is a data structure where insertion should be done in one end and deletion can be done in the other end, right? Suppose this is a data structure queue, and suppose we are representing queue in an array. If we are using array for queue representation, that means the size should be mentioned, right? Suppose the size of this queue is 5. So we can store maximum how many elements? 5 elements. There are total 5 spaces, for inserting 5 elements. So 1, 2, 3, 4, 5. Okay, and in queue data structure, the operation insert and delete, we should use the term enqueue for inserting the data element, and we can use dequeue, right? Dequeue for the deletion operation. So now if we want to insert a data item, suppose 7, why we should insert it?
1, madam.
Queue is a data structure where enqueue and dequeue should be done in 2 different locations. Suppose this is a front end of the structure and this is a rear end of the structure. Okay, so initially when the queue is empty, suppose initially the queue is empty, and if we're using unit based indexing, then the pointer value front equals to 0 and rear equals to 0, right?
Yes, ma'am.
Initially when the queue is empty, then this pointer value should be same, f equals to 0, r equals to 0. Now if we want to perform an operation that is enqueue, why do we insert it?
In the front.
The capacity of the queue is 5, but it's actually empty, right? So in this location, we will insert the data item, suppose 7. First location, we will insert the data item 7. So at that time, when the queue has only one element, both the front and rear pointer value will be same. F equals to 1 and rear equals to 1. When the queue has only one element, that means the front pointer value and the rear pointer value should be same. Okay, now after that, if we want to insert another data item, such as suppose 15, where will insert it? In the rear side.
Location 2.
In the rear side. So at first, we have to increase the rear pointer value, and its new value will be 1 plus 1 equals to 2. So in this location, we can insert the second data element 15. And here front equals to 1 and rear equals to 2. After that, if we want to insert another data element such as 18, I will insert it in the next memory location. Just again increase the value of r by 1. Then this will be the value of rear pointer, right? So here in this location we can insert 18. So this is the enqueue operation. Insertion can be done on which end? On the rear end. Okay, so after that, if we want to delete a data, so we can mention the operation name dequeue. Okay, and in queue data structure, always the first element should be removed first. That's why it's not mandatory to write, add any arguments here. Okay, so which data element will be removed now? 7.
7.
Because front equals to 1. From this position, the data element will be removed. After removing the data item, now we can increase the value of front pointer by 1. When the first element is removed from this queue, now the first element is 15. So now front equals to 2. What about rear? Rear equals to 3. Look at this queue. Which one is the first element now? After removing 7, now 15 is the first element, and this front pointer it will always hold the position of the first element of this queue. So here front equals to 2, that means 15 is the first element, and here rear equals to 3, so 18 is the last element of this queue. But what about the size? The size is 5, that means the queue can take maximum 2 more elements. We can insert 2 more elements in this queue. Okay, so after inserting, suppose another element 11. So now what is the value of front and rear? Front equals to 2. It will not be changed because we didn't delete any data element. But after inserting another data item, now the rear pointer value will be changed. Rear equals to
3 plus 1. 4.
3 plus 1, that is 4. Okay, now if we delete another data element from the queue, which data element will be removed first? So obviously 15.
15.
In queue data structure, the first element will be removed always first. So 15 will be removed, and after that, this 18 will be the first element of this queue. So now the new value of front pointer is 3.
3.
So now the queue has two elements, 18 and 11. After that, after another in queue operation, we can insert another item, suppose 17. Okay, and now this is the new value of rear. Rear equals to 5.
5.
Okay. So now if we want to execute two dequeue operation, then what will be the value of front and rear? In
5.
queue data structure, the the complexity of NQ operation and DQ operation is always order of 1. We cannot add or we cannot delete more than one data elements at a time. So after deleting the front element, that is 18, then we can delete 11, right? So after deleting all these elements, now the queue has one element, and at that time also the front value and rear value will be same. Now front equals to 5 and rear equals to 5.
5.
That means the queue has only one element. So after that, now if we want to insert another data element, suppose 21, is it possible?
No, ma'am.
But look at this array. There are 4 available spaces, right?
But we can insert only in the rear.
Element, there are 4 spaces, but we cannot insert it because this type of queue is called linear queue. Linear queue or single queue. That's why the insertion can be done only on one end, only in the rear end. That's why, this is the disadvantage of linear queue. And in some spaces, we are just wasting some spaces, right? So that's why we can use another type of queue, which is called circular queue. Okay, so if the queue is, now we can take another queue. Suppose this is another queue with the capacity 4. That means it can store how many elements? 4 elements, 1, 2, 3, 4. And the data elements can be inserted one at a time. So you can insert 10, after that 20, 30, 40. So now we want to delete one element from this queue. So which one will be deleted? 10. So after deleting 10, what is the value of front? 2. And the value
2.
of rear is
4.
And the capacity of this queue is 4. So, but after that, now we want to insert another data element, that is 15. The maximum size of this queue is 4. And here, is this full? How will we decide that whether the queue is full or not? We know that on a queue we can perform 5 types of operation, that is in queue, DQ,
Is
and
empty.
then is empty, very good.
Is
Then
filled.
is full,
Is full.
and then peak.
Peak.
These 5 types of operation can be done on queue, right? So in queue, that means insertion operation. DQ means removal of any data element, and is empty, that is we have to check whether the queue is empty or not. And when this operation will be true? When is empty operation will be true if f equals to 0 and if rear equals to 0, that means the queue is empty. At that time, the output of this operation will be true. And what about is full? Suppose for this queue, the size is 4, the maximum capacity is 4, and here front equals to 2 and rear equals to 4. For insertion operation, we always use the value of the rear pointer. Here r equals to n, that means the queue is full. When r equals to n, we can say that the queue is full. Okay. And what about peak operation? In peak operation, actually we're not inserting any new data element or we're not deleting the data element. It will just return the value of which pointer? Front pointer. It will always return the value of front pointer. So here, after executing this operation, it will return the value 2 because 20 is the first element of this queue. Okay, so here you can say that r equals to 4, that means the queue is full. So we cannot insert any new data element here, right? And this is a property of single queue or linear queue. Single queue or linear queue. But suppose we have taken a circular queue, okay, So now in circular queue, this type of, insertion is possible. Suppose after deleting some data elements, now some empty spaces are created. If we want, we can utilize those space for inserting the new item. So actually this is the structure of circular queue. Just look at this. So initially, how many elements are here? Suppose 4 elements, that is 10, then 20, and then 30, 40. Okay, so suppose the element 10 is removed. 10 is removed and 40 is the highest element, or its position is equals to n here, right? So after that, if we want, we can move on to the next position. It's possible in circular queue. If we want, we can insert a new data element in that empty space. But in linear queue, it's not possible. Is that clear? So now in circular queue, we have to modify the condition that we used in the linear queue. In linear queue, the rules or condition for inserting any new data element is if R is less than, or how many times you can insert the data item here? What is the condition? While R less than n, then we can insert the new data element. Isn't it?
Yes, ma'am.
Yes, ma'am.
When R equals to 1, at that time 1 is less than 4, so we can insert a new data element. But when R is equals to n, at that time we can't insert any new data element. So that is a condition we can use in linear queue. What about the circular queue? If I take another queue, so after deleting 10, now this is an empty space, okay? And this is the second element 20, the third element is 30, and the fourth element is 40. Okay, and the size is 4. Now we want to insert another item 50. So where we will insert it? In the first location. Now the rear pointer value, how it will be changed? In the linear queue, the rear pointer value was changed in this way, R++. We always increase the value of rear by 1, but here we cannot apply that rule here, right? If we increase the value of R by 1, at that time R equals to 5. That means R is greater than n, which is not possible. That means we have to modify the rule here for inserting the new data element. And the rule is if rear modulus n equals to front, that means the queue is full. What is the value of rear now?
4.
4.
And what about n?
4.
4.
Before deleting the data element, okay. 4. And what about n? Sorry, f. What is the value of f?
0.
0.
What is the value of f?
One,
What is the value
one,
of front
one.
pointer?
Oh, 1.
Very good,
One,
1.
one.
So now look at this. 4 modulus 4, 0, and the front value is 1. The condition is here for this operation is full, that if we use the condition R modulus n equals to f, R modulus n equals to f, that means the queue is full. But here we can see that the values are not same. And why this problem is happening? Because we used unit based indexing. Now look at another array or queue where we can start from 0. Suppose the position of the first element is 0 and the second is 1, 2, and this is 3. How many elements you can store here? How many elements? N equals to 4. N equals to 4. But after inserting all these data elements, 10, 20, 30, 40. Okay, now tell me, what is the value of front pointer and rear pointer? Here front equals to 0 and rear equals to
3.
3. And how we can modify the condition in linear queue? In linear queue now the condition will be if rear is greater than n minus 1, that means the queue is full. Look at this. Here R equals to 3 and the condition is if rear equals to n minus 1, then we can say that the queue is full. So r equals to 3, n minus 1 equals to 3. So this is for linear array. What about circular array? In circular array, if we say that r plus 1 modulus n equals to front. What is the value of r here? R equals to 3. 3 plus 1, that is 4. 4 modulus n. 4 modulus 4 equals to 0. And that is the value of front. Isn't it?
Yes, sir.
Here r equals to 3. 3 plus 1, that is 4. 4 modulus n equals to 4 equals to front. What is the value of 4 modulus 4? The value is 0 and f equals to 0. At that time, you can say that the queue is full. That's why in circular queue, we prefer to use which type of indexing? Zero-based indexing. We can use unit-based indexing also. At that time, we have to subtract 1 from n, then we have to change the value of f. That's why it's easier to use zero-based indexing in circular queue.
So ma'am, it is better to use always zero-based
Yeah, zero-based. Actually, it's safe to use zero-based indexing. Okay, so now this is a circular queue with n equals to 4. Okay, so 1, 2, 3, 4. And the first element is deleted. Now front equals to, or we can zero-based indexing, 0, 1, 2, 3. After deleting the first element, now front equals to 1. So it's 20, 30, 40. Okay, r equals to 3. Now how we can check whether the queue is empty, the queue is full or not? How we can check it? How we are going to check the
r
condition?
plus 1 modulus n equal f.
Very good. So now it's just, we can use the same equation, r plus 1 modulus n equals to f. Why we're using the condition? To just find it out whether we can insert any new data element in the queue or not. Okay, so now r equals to 3. And what about n? 3 plus
3.
1 modulus 4 equals to front. So here 4 modulus 4 equals to 0, and what about f? F equals to 1. So these two values are not same, that means the queue is not full. We can insert a new data element, but where we can insert it? Before inserting a new data element, we have to change the value of rear. In linear queue, we can simply increase the value of rear by 1, then you can insert the new data element there. But it is circular queue, so the new value of rear will be rear plus 1 modulus n. The new value of rear is r plus 1 modulus n. So what is the value of rear? 3. 3 plus 1, that is 4. 4 modulus 4 equals to 0. So this will be the new value of the rear. And in this position, we can insert the new data element 15. And this is the advantage of circular queue, that is, we can reuse the memory spaces. Initially, this location 0 has the data element 10. After deleting it, an empty space is created. And by using a circular queue, we can reuse that memory location for inserting another data element. Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay. So now if we delete another item, so which data element will be removed from the queue? Although in this location 0, we have a data element 50, but 50 is not the first element of the queue.
20.
50 is actually the last element of the queue because r equals to 0. And the rear pointer always denote to the last element. And what about the first element? Here f equals to 1, that means 20 is the first element of the queue.
First element.
Now if we want to perform another dequeue operation, which element will be removed? 20.
20.
After removing 20, now the new value of front will be 2. That means 30 is the first data element of the queue now. That is the first data element of the queue. Okay, so now if we want to insert another item 60, where will insert it? Again, the value of r will be changed.
At
How?
location
By
1.
this equation. R equals to r plus 1 modulus n. And now what is the current value of r? 0. 0 plus 1, that is 1. 1 modulus n, that is 1 modulus 4. What will be the value? 1 modulus 4. 1 modulus 4, that means we are dividing 1 by 4 and then we have to take the remainder value. And how many times you can divide 1 by 4? 0 times. 4 into 0 equals to
0.
And the remainder value is 1. And this is the result of this modulus operation. 1 modulus 4 equals to 1. So now the new value of real will be 1. Okay, so now we can use this location, this space for inserting the data element 60. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay, so now this queue has how many elements? 4 elements.
4 elements.
And
Four
front
elements.
equals to 2 and rear equals to 1.
1.
So can we insert any more data elements here? Can you insert any new data element here?
Ma'am, if you want to add,
Yes,
then
ma'am.
we have to perform the DQ operation first.
Which operation?
DQ, I mean, have to delete, we have to remove, remove an item, then we have to add. As we have the
But
size only 4.
suppose you, yeah, it's not, I mean, you don't need to remove any data item. You just have to check whether the queue is empty or full. Is it
Yes,
full or still it has some spaces for new insertion?
Ma'am, currently it's because already one
It's full.
location 1 has already containing the items.
Yes, so that means the queue is full and we can use this equation always for finding it out. Okay, so that is the insertion and deletion in circular queue. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so in the next class we'll discuss about another type of queue, that is DQ or double-ended queue. So now please response 1,
Yes, ma'am.
2,